Today, I'm going to be talking about word problems and how to solve them, and I'm going to be looking at several different types. My name is Ann Scanello, and I'm one of the tutors with the Seeds of Literacy program. So the topics that I'm going to be including today are a little bit of basic word problem skills, fractions, positive and negative numbers, perimeter and circumference, and then also area. I took many of the problems, but not all of the problems, from these 5 Seeds of Literacy packets. So some from graphing and inequalities, basic geometry. This is it says mathematics skills book, solving word problems. The packet with adding like fractions, which is adding and subtracting fractions actually in there. And then problem solving and application. I want to start with some basic, I guess you could call them notes or information about when you're solving word problems. In a couple of the Seeds of Literacy packets, they had some good note pages, and this is one of them. It's full of keywords that will help you know if you should be adding, subtracting, multiplying, or dividing. First thing I want to say is, in my experience, students sometimes have more trouble when they rely too heavily on lists like this. But I still think that there is some good information that can be gleaned. First of all, the word of. Just about every week when I was in Seeds of Literacy tutoring people in person, I would find myself teaching this little mini lesson over and over and over. A good piece of information is that if you can restate a word problem using the word of, then that's going to be a multiplication problem. And we're going to have at least one practice problem like that. We might actually have 2, I don't remember. But some other words that I thought were helpful. When you're adding, you might hear the word combined. That comes up a lot. When you're subtracting, when you're asked to, if things are nearer or if things are farther, that's a good keyword. When you're multiplying, of is the number one helpful keyword for me anyway, but a lot of times you'll hear twice or 3 times the number. And then for division, see if I can see these. Oh, a lot of times you'll hear the word average, or anytime they're talking about equal pieces or sharing something or splitting something. Those are all keywords indicating that you are probably going to have to divide those numbers. And something I wanted to warn you about, terms like, you hear people say an addition keyword might be all together or in all, but those are really just words that means that our numbers are going to get bigger. And so you will see those same words in addition and in multiplication problems. So they are just terms. If it says, how many will you have all together, you expect your numbers to get bigger. And then, thought I had one more. Oh, and more than. This one also can be confusing. More is a keyword for addition, but if they're asking how many more than something else, that's a keyword for subtraction. So don't rely too heavily on keywords, but they can be a hint to your equation. This is another one of the Seeds of Literacy packets, and they again have got their list of keywords. The one thing that I thought was different that I really liked out of this set of notes is you need to choose division if you have many and you want just one. And then, of course, also if you're averaging or equal pieces and or amount of each, like we talked about. But a lot of times, you will be starting with a group and they say, how about if you just have one? That's an indication you're going to be dividing in that problem. Okay, so I divided the word problems into different groups, and we're going to start with the unit conversions and the fractions. And Lana, do you have a calculator with you today?
Give me one moment. I can get one. Unit conversions throw off so many people.
Oh, I know. And Lana, I think, will do very well with this. But
Give me 1 second. I'll be right back.
some people, challenging.
Okay.
You got your pencil and paper?
Yes. Pen, well, actually, pen and paper.
Okay.
And I
Pen and
have
paper. Hey, it all works. Okay. So, starting with unit conversions and fractions. Our first problem, if I can get it where I can see them. Okay. Our first problem says, Bill needs 109 inches of baseboard to place along the family room floor. Will a board that is 8 feet long be long enough? Okay, so Lana, my experience with you is that you probably are going to be just fine with this problem. You want to try and solve it and tell me what you get?
Okay. Should I use
Or
the
if you want to do it together, we can do it together. It's up to you.
Okay. Should I use a calculator or should I just use paper?
In my experience, when the numbers get this large and the big idea is to have you do some conversions, calculator's probably going to be okay. So
Okay.
I would be comfortable telling you to use a calculator.
Okay. 1 second. I have so many calculators on here. Okay. So Bill needs 109 baseboards to place on the family floor for a board that is 8 feet long. Oh. So I know it's 12 inches in a foot.
Hmm?
So let me see, I'm gonna divide 109 by 12. 9. Ooh. So it won't be enough because it's coming up as a 9 versus 9.83333.
You know what? That's awesome. And Lana, you had a different strategy than I had. So I'm glad you said that. So you took the 109, you knew 12 inches in 1 foot. So you divided that and you learned that you were going to need 9 feet. Okay. I solved it a little bit different way, but arrived at the same answer. So I said that I always like to write down my known information before I start. So 109 inches is how much I need. 8 feet, I need to know if that's going to be long enough. So I used the system back in the olden days when I was learning unit conversions. I used this system that I'm going to show you right now. Some of our future problems, I'm going to be using like my old system and then also just reasoning skills, because I think in today's classroom, they teach reasoning more than this kind of formula proportion system. Okay, but so in the olden days, we would do 8 feet would be like one project, 12 inches is 1 foot, and so 8 feet of the board that we have is going to give us 96 inches. And then 96 inches is less than 109 inches. So no, Bill will need more baseboard. So we ended up at the same place. Okay, so let's try this one. Barbara has 25 decorative bricks. Each brick is 14 inches long. If the bricks are placed end to end in a straight line, what distance will they cover? And then importantly, it says, give your answer to the nearest foot. You want to try that one?
Okay, let me see. In a straight line. What is this? It will cover. So I'm just going to do 14 times 25. Hmm. Gotta redo this because I don't know how to work this scientific calculator. I
Oh,
entered
is that the problem?
huh?
I was wondering. So it's not your cell phone are you on a cell phone or something?
Yeah, but this is a scientific calculator
Okay.
on
So
the
they
phone.
didn't give you the simpler one. Okay.
Okay, so I'll
Well, you
just
want to know what? I can be your secretary. I got a regular calculator. So tell me what to punch in and I'll do the calculator part for you. What do you want me to punch in for you?
14. Well, on here I punched in 14 IN. I'm assuming that that's stood for inches.
You want to know what? And that's confusing your calculator. Don't put in the units. I would never put in the units.
Okay. So, and I multiplied that by 25,
Okay.
and that's 350.
You're correct. Yes. Okay.
So I'm assuming, you said that needed to be in inches?
They want our answer to the nearest foot. Yeah. So your answer would be inches so far.
350. So then I'm going to divide that by 12. Let me see. 12 equals, so then that would be about 29.16666666667
Okay.
feet.
So what's the answer? They told us give your answer to the nearest foot. So what would that answer be?
Then I would just say 29 because on the other side of it, it's just 1. I know if it's 5 or greater, it goes up. If it's less than that, then it just either stays as is or drops down 1, something like that. So I just say 29.
Yeah, perfect. Absolutely perfect. Okay, so the way I did it, let me see. We had 25 bricks and 14 inches. And so like you could reason it out. Oh, well, then I'm going to have 25 sets of 14 inches. That's going to be 350 inches. You know that there's 12 inches in 1 foot, so we're going to divide by 12 to come up with 29.16 repeating. And I get so many students tell me that that means 29 feet and 16 or 17 inches. And that absolutely, and I'll have other students say, I know that that's not right. And they'll say that's like 29 feet and about 2 inches, but that is not correct. And I was glad to see that they didn't have us do that conversion to inches. I'm not even going to show that because for this problem, we didn't need it. I'm just going to say the correct answer would be approximately 29 feet. They wanted to the nearest foot, and that's what it would be. So, this is that other system that as when I was a kid, this is how I learned it. We would have written 25 bricks over 1 project because those are equivalent. And then, so we just have to keep writing equivalent comparisons. So then 14 inches is the size of 1 brick. So that's like, 1 over 1 because those are equivalent. And then 1 foot over 12 inches, those compare. And then we would cancel out. So the brick cancels with brick. And then inches cancels with inches. So when we're done, we have 29 feet for 1 project. So, Lana, I'm assuming that you're too young for this system. Does this look familiar to you at all?
It does, and I'm a senior citizen, so I'm very familiar with it.
Okay.
But I never understood it when they was trying to teach it to me because it doesn't make sense to me.
And I remember way back in the olden days sitting in class, and I loved that system, and that made so much sense to me. But I also remember that was kind of the point where the teacher lost a lot of the classroom. So, and today I haven't seen that system taught in several years. And so the reasoning is probably it is a better way to teach it. I just wanted to be able to show both systems because I never know at Seeds. I have had students my age or a little bit older, and sometimes people will respond to one method over another. Okay, nice job. Okay, so the next one. This is going to be a fraction problem. And it says Jeff weighed 166 pounds. He went on a diet and lost 11 3/4 pounds. How much did Jeff weigh after his diet? So see how you do with this one. I've taught a lot of fraction lessons in the last couple of weeks, but
Oh my
so
God.
you might need a refresher because I don't know how long it's been since you've done fractions.
I'm horrible at fractions, but I'm gonna try.
Okay, you try, but if you want me to help you, just let me know. And I can give you hints.
Okay. So he was 119 pounds after his diet.
Don't you wish it worked that way? Don't you wish if you weighed 166 pounds and then you lost almost 12 pounds that you'd be down to 119? Well, I could use that. But that is not quite right. Let me see what you did here. Okay, so I wrote the problem up and down. In the Seeds packet, this is how they write the fraction subtraction. And it really can be helpful to write it like this. So the next thing they teach is that we're going to subtract our fraction part first and then our whole number part. The thing is, we don't have a fraction part here. And so it's impossible to say nothing minus 3/4. They aren't going to let us put negative numbers in the middle of our problem. So we have to rewrite 166 a different way. And this is the part that it's awkward. So 166 is really the same thing as 165 and 4/4. Because 4/4 is 1, and then 165, and you put them together, you have 166. But the reason we do that is because now our problem is 165 and 4/4 minus 11 3/4. And from this point, see if you can finish out the problem and see what answer you get this time.
$154 pounds and 1/4.
You're awesome. That's it. Nice job.
I would have never thought to do it that way. I did something completely different. I sit up there and you know how you multiply your numerator or denominator with your the whole number and add the numerator. That's how I came up with that first one. But then the other one just seemed to, after you showed demonstrated, it just made sense this way. I would have never thought of that.
You want to know what, Lana? You and I must be the same age. Because that is how I learned how to do it.
I will be 50 this year.
How old are you?
I will be 50 this year.
Okay. I will be, how old am I? I was born in 1964. I think I'm 55. I'm 55. And that's how I learned it. And so when I'd be working with students at Seeds, I was kind of doing it that way. And that way absolutely works. There are just more steps. And the last step that you had to go through can be very confusing. And so I think you just made an error in there somewhere. So when I had to teach this fraction lesson for, on as a video a couple of weeks ago, I thought, now I understand why they always write the subtraction, one on top of the other. So anyway, there's a whole video on it if you're interested. Okay, let's try another fraction then. So this one says, so far Mary has run 7 3/4 miles. She tries to run 10 miles each week. How many more miles does Mary need to run to complete 10 miles? So see if you can do that one.
Oh, wow. Three-fourths. 2 1/4.
That sounds good. Let's see here. So 10, let me see. Oh, you're awesome. Look at you. Look at you go. We match. Perfect. Mary needs to run another 2 1/4 miles to complete it. Good job. Okay, we have another one. A paving crew has 7/10 mile of road to pave by May 14th. The crew hopes to complete 2/3 of this by May 6th. What length of road does the crew hope to finish by May 6th?
Wait a minute.
You read it. Read it out loud and then read it silently to yourself. That helps me process.
Okay, a paving crew has 7/10 mile of a road to pave by May 14th. The crew hopes to complete 2/3 of the road by May 6th. Let me see, 5, what is that, 14. The other one is 5, 6, okay. Says, what length of the road does the crew hope to finish by May 6th? Okay. Oh, I'm really not sure about this one, but I'm gonna try to do this 2 different ways.
Okay.
I'm not so sure about this one.
Tell me what answer you got, and then I'll give you a hint if you need one.
Okay, well, first I assume maybe if I try to do some cross cancellation, I'm like, no, that doesn't make sense. And then I was thinking, well, this, it's like numbers that can go into the other numbers evenly, or like, I don't know. I can really say I really don't know.
Okay. So this is one of those examples. And like I said, almost every week at Seeds, and when I was teaching math, I taught this little mini lesson 1,000 times over. In a word problem, if you can restate it using the word of, then you know it has to be multiplication. And so this one, my brain says, paving crew has 7/10 mile of road. They want to complete 2/3 of that amount. So they're asking us, how much is 2/3 of the 7/10? Does that make sense? It's like, really, they want to know, how much would 2/3 of the 7/10 be? So now, because it can be stated as of, what's the operation that goes with that? Oh, you're awesome. You are good. Okay. So, but Lana, if you gave that answer, let me get to that point. Let me catch up with you. Especially if it was multiple choice, which a lot of times it is, that would not be one of the options. So you're going to have to simplify it to put it in what we would call proper format. So what would 14/30ths be?
2/15.
Nice job. That's it. You're going to divide the numerator and the denominator by the same number, and 2 works on this one, and you come up with 7/15. Good job.
Oh, I came up with 2/15.
Oh, I'm sorry. I was thinking maybe I had 2 in my head because I knew I had to divide. Yeah. So we're going to have to find a number that divides evenly into both 14 and 30, and that number is 2. And so do you see why it would be 7/15?
Yeah. But I don't know. I guess when I think to simplify something, I would think of the smallest number, because I do know that 2 would go into 14 7 times.
Okay.
But instead of me putting 7, I just put 2.
Yeah.
And I know that 2 would go into 30 15 times, but I don't know. See, that's where I get confused at. Kind of like,
your thought process was absolutely correct. And it might actually, while you're practicing your fractions, it might help you to write it out the way I did, because you know that 2 is important. 2 is the number that's going to divide evenly into both of those. And so I wrote divided by 2, divided by 2. We can do that because 2 over 2 in a fraction, it just has the value of 1. So, and so maybe if you had a place to show the 2, it would be easier to see 14 divided by 2 is 7, 30 divided by 2 is 15, which you knew all that information. It's just to write it down in an organized way. Okay. And then, so I can't even remember. Okay. The crew should have 7/15 of the road complete by May 6th. I would say a problem like this would be challenging for most students. It just sounds weird, and you throw fractions in there, but whatever system you use, before you move on to the next problem, ask yourself, does my answer make sense? I mean, the road is not going to be all the way finished by May 14th. So certainly by May 6th, you're looking for an answer that is less than finished, that is a smaller amount. And so sometimes, that will help you if you wound up with an answer that's, like, 2 miles or 3 miles. It helps you to see, oh, wait, I must have done something wrong, and rethink it. Okay. Here's another fraction one. It says, a cookbook recommends 1/3 hour of cooking time per pound to cook a roast medium well. Following these instructions, how long should a roast weighing 8.5 pounds be cooked if the chef wants it medium well. Okay, you want to solve it?
Okay, I'm gonna try. So,
And while she's still solving this, I just want to say problems like this are why my stuff always comes out either burnt or uncooked.
Right. I can, and it's not the math that messes me up when I'm cooking, but yeah, no, I can totally relate to burnt or uncooked.
Yeah.
I just don't have a good excuse.
I'm really not sure how to figure this out because I lined it up where I put 8 1/2 over 1/3. Then I said, oh, that doesn't make sense. So then I turn around and then I figured 1/3 is like what, 75 or something like that. I don't know. And
Okay.
I tried to multiply that. I really don't know how to figure that one out. I know it's
Okay.
probably.
So the best thing, and that's what happens when we get math word problems. Everyone knows they have to write an equation and they want to go straight for the equation. And that's when you have that list of keywords. You're trying to pull out, oh, I see this word, I have to divide. I see this word, I need to subtract now. And I try to get students to think more, to reason more than to just go straight for the equation. So for a problem like this, because it is a challenging problem, just because it can be confusing, if you're going to spend 1/3 of an hour cooking 1 pound, how long would you spend cooking 2 pounds?
2/3.
Nice. Okay. So what if you had to cook 3 pounds? How long would that take?
That would be 3/3, which really would be 1 hour.
Okay. So you honestly could keep bumping up like that, but you could use that patterning to help you figure out a better equation. So we said, let me see, 1/3, I'm sorry, 1 pound took 1/3 of an hour, 2 pounds took 2/3 of an hour, 3 pounds took 3/3. Let me see, so how much would 4 pounds take?
2 hours, 2 hours and 2/3.
Are you answering for 8.5 pounds?
No, I'm answering for 6.
Oh, 6. Okay. Because let me see. So the problem says 1/3 of an hour per pound for 1 pound. And we're going to cook it now for 8.5 pounds. So let's just work on the equation. So we thought about it, 1 hour is 1/3, 2 hours is 2/3, 3 hours is 3/3. What equation could you, so if it was 4 hours,
There was 4 hours, then let me see. Let me see.
okay, Lana, I'm going to try, I set up my whiteboard a long time ago and I almost never use it anymore, but I'm going to use my whiteboard to kind of walk you through this one. Are you able to see it on the screen?
Yes.
Okay. So we said 1 hour we said 1/3 of an hour would do 1 pound. Okay. And then we said it was going to be 2/3. Let's see. 1/3 of an hour. And if we had 2 hours, then that was going to be 2/3. Because you told me if 1 pound takes 1/3 of an hour, then, see, this was pounds. Okay. 2 pounds was going to be 2/3. And then you also told me that 3 pounds, put P, was going to wind up being 3/3. Okay, so think about this. What equation could you have written? 1/3 something, some operation, 2 pounds equals 2/3. 1/3, some operation goes in there, so it's going to equal 3/3. Can you figure out what we're doing each time? Are we adding, subtracting, multiplying, or dividing? What operation of those 4 could I put in that blank?
I think we're adding.
Well, so let's try that. So 1/3 plus 2, do you know what 1/3 plus 2 is?
1/3 plus 2 would be 3/3.
Actually, it would be 2/3 because it would be 2, and I'll write it up and down the way they do in the seeds packets, plus 1/3. Can you see that? Okay. So I have to add my fractions, and I've got nothing there. So I've got 1/3 at the bottom, and now I'm going to add my whole numbers. So now I've got 2 and 1/3. So adding doesn't work. So what else should we try? We tried adding and that didn't work. What else? What other operation could we try in there?
The other one, based on the chart I saw, it had similar words. The other one would be multiply.
Okay, so let's try multiply. I'll put the little X in there to show multiplication. Okay, so now I'm going to write it over here bigger so you can see it. So it's like 1/3 times by 2 pounds. And remember, when we're multiplying fractions, we really need to have two fractions there. And right now we've got a fraction and a whole number. So the rule is any whole number can turn into a fraction if you write it over the number 1. So now we just multiply across. 1 times by 2 is 2. 3 times by 1 is 3. So the answer is 2/3. So multiplication is correct. So we can try it again on this one. We said, let me see, if 1/3 of an hour will cook 1 pound, then if I need 3 pounds, I can do that 3 times. So it would be like 1/3 times by 3 pounds. I'm going to put it over 1 because I need 2 fractions to multiply together. I'm going to multiply across, and I'm going to end up with 3/3, which I think you told me before is the same thing as 1.
So it's 1 hour and 2/3?
That would be 3 pounds. Okay, so now for the whole problem, we need to write it. Let me erase this. We need to write it using multiplication. So we have 1/3 of an hour will cook 1 pound, but we need to cook 8. I'll write it this way. There's different ways to write it, but we need to cook 8.5 pounds. Okay, but before we can work this problem, we have to convert 8.5 to an improper fraction. Right now it's a mixed number, and when it's a mixed number, we can't multiply it. So this is what we were talking about on that earlier problem. Can you turn 8.5 into an improper fraction?
Yep, you multiply 2, 8 is 16, plus 1 is 17, and 17 over 2.
That's it. So 8.5 is the same thing as 17 over 2. Okay, so now see if you can multiply this one.
Am I multiplying straight across?
Yes, whenever you multiply fractions, you just multiply straight across.
So it's 17 over 6.
Perfect. Okay, now that's what we call an improper fraction. And I will say, and even though it's an improper fraction, that is absolutely a correct answer. But they're going to want you to simplify that or turn it into a mixed number. It's going to be a lot easier to understand as a mixed number. So can you write that as a whole number plus the fraction?
Yeah, by dividing it, 6 goes into 17. Let me see, 6 and 3 is 18. So I would say 2, that's 12. 12 with a remainder of 5.
Good.
Over, I don't know.
You're so, now you've got, I can tell, I feel like you and I had the same math teacher way back in the day because we speak the same language. You knew the whole number was 2 because you can get 2 full groups of 6 in there. And so you had 5/6 left. We had a total of 17 6. You pulled out 2 full groups, or you pulled out 12 of the 6, and we were left with 5/6. Did you follow that?
I don't know. I got something. Well, let me show you real quick. I'll make this quick.
Hi.
Hello, is that Talisha?
Yes, I'm so late. I've been so busy, and I so forgot.
Not a problem. It's funny. Lana is a student who was coming every single lesson for like the first month. Then we probably even mentioned her to you. And then she, the last couple of weeks, had other stuff going on. But she came back today, and I told her, I said, we even waited. We said, Alicia will probably be on. We'll give her a minute. But it's funny because the problems that you've missed are the problems like the fractions and the unit conversion and some of the stuff that we've done over the last couple of weeks. So the second half of today's lesson, I'll wind up teaching next week. And that will be some of the stuff that Lana did with me, but you haven't done. So that's perfect. But anyway, Lana's in the middle of solving this problem that's on the screen. Talisha, you might want to see if you can work it. This one's a challenge problem. A cookbook recommends 1/3 of an hour of cooking time per pound to cook a roast medium well. Following these instructions, how long should a roast weighing 8.5 pounds be cooked if the chef wants it medium well? So Lana's working it and she's checking her work. And Talisha, you go ahead and try and solve it. And Talisha, when you get your answer, let me know. And then Talisha's writing for me on her whiteboard. I'll have to see if I can squint and see that better.
I'm trying to show you how I messed up. I don't know.
I see what you're doing. Okay, now I can see it. I figured out how to make your picture bigger so I can see it now. Okay.
So I guess this is where I was getting confused, where
Okay.
I was going, about 1/3, 2/3, 3/3. So I know that made 1.
Okay.
So then, and this was done 6 times. So that's how I came up with the number 2.
Nice.
So let me see. So that's 6. So for 8, because that would have been 2 more. I guess that's why I got lost with the 2/3.
Yeah. I love your reasoning. And I'm telling you, for a lot of problems, you would have been successful. But you still have to figure for that extra 1/2 pound. So you still have to do 1/2 of 1/3. Because it's going to take, well, we can even talk minutes. If it's going to take 20 minutes, that's 1/3 of an hour to cook a pound. How many minutes will it take to cook 1/2 pound?
So would it have been 3, 2 3/5?
No. How did you get the 3/5?
Because let me see. I'm trying to put it where you can see it because I know it's got a little gloss here.
Oh, the reflection is not messing me up. What? Oh, I see what you did. Look at the right part of your screen, Lana, where you have 2 2/3 and then you have 1/5. You just add, and I'm sorry, then you have 1/2. You just added. And when you're adding fractions, it's not like multiplying. You have to have a common denominator. The number on the bottom has to be the same. But then the other problem that you had is we really didn't need to add them. We needed to figure out that extra 1/2 of an hour, extra 1/2 of a pound, how long would it take to cook?
Okay.
I like the system, but so if we had to say 1/2 of a pound is going to take 1/2 of the 1/3 hour. Do you know how to solve 1/2 of 1/3 hour?
No, I think of is what was that? Was that division? Those words.
Multiplication. And of all those key words, that to me is the most important one. So you need to know 1/2 of 1/3. So that's multiply. So see if you can do that.
So would that have turned to 2 6? 2 2 6?
Okay, so you had 1/2 of 1/3. So you're multiplying across. And that would have been 1/6. But now don't forget, you already had the 2/3. and
I guess I'm not
2/3.
sure how you got the 1/6 because I had the 2/3 and then I put the 1/2. So if I was going across, then it would be 2 times 1 would be 2, and then the 3 times 2 would be 6.
Yeah, but over there on the right side of your screen,
Mm-hmm.
it wasn't 2/3 times by 1/2. We have to go back to our problem. The problem says 1/3. So on the bottom of your screen, can you write this for me?
Okay.
Okay, so you're writing 1/3 hour, or just 1/3. And where's Layla? There she is. 1/3. And we need to write 1/2 of 1/3 because we don't need the whole third of an hour because we're not cooking the whole pound. So we're doing 1/2 of 1/3. So write that equation that would go with 1/2 of 1/3.
Okay.
Good. And what's the operation? Multiplication. Perfect. Now multiply those two things. So what's that going to be?
1/6.
Perfect. Okay, see, now so it's going to take 1/6 of an hour to cook that half of a pound. So you have to add that 1/6 to the, what did you have up at the top?
The 1.5, 8 and 1/2, 1.5. That one.
Can you scroll? I want to see the far left of your screen.
Okay. Let me see.
Oh, did you rewrite it?
This is my right. So you need the other side because this is my right.
No, you see where it says, oh, is that your right? Thank you.
Yeah.
I think you have 2 and 2/6.
Oh,
You have 2 and 2/3. It used to say 2 and 2/3, but then you did some weird conversion or something. Put it back to 2 and 2/3 up there. And you're right. It's probably,
right here.
nope, on the other side. That used to say 2 and 2/3.
Yeah, right here.
Yeah, so change that back to 2 and 2/3 because that's what we had after 8 hours. So when you were adding on each pound, it's going to take another third of an hour, you got up to 2 and 2/3, and that was going to cook 8 pounds. Now
Okay.
to cook the final half of a pound, it's going to take 1/6 of an hour. So now up there, we need to write 2 and 2/3 plus 1/6. Nice. And now that's the problem you have to solve. And remember, we have to have a common denominator, and you can't just add those.
Okay. So what goes into 3 and 6 evenly? 2.
Well,
No, let me see. 3, 12. Because 3 can go into 6. 3 can go into 3 one time. 3 can go into 6. Both of them can go into 18.
hold up. You're getting into some really big numbers, and you're making the problem harder. We need a number that 3 and 6 both divide into evenly with no remainder. And so the system that they use in one of the seeds packets is they say, take all the multiples. So you're going to write 3 and 6. Actually, we'll look at my screen now. I'll put it back up on my screen. So they say we need a common denominator, and our numbers are 3 and 6. So all the multiples of 3 would be like 1, 3, 6, 9, 12. And so let's write some multiples of 1 is not a multiple of 6. So it would be 6, 12, 18, 24. And they say when you get a list now, pick the smallest number that they have in common. So what will both 3 and 6 divide into evenly? What number, Lana?
6 is the smallest one.
That's it. So 6 is going to be you could have used 12 and you could have used 18. It's just going to be more calculations.
So it would have been 2 and 3, 6. 2 hours and 3, 6. But then would I multiply that to make that a whole number? No.
Nope. So we had 2 and 2/3. Okay. So we need to turn 2/3 into 6. So 2/3. I want to know how many 6 will that be?
Oh, Lord.
Okay. So let me see, 3 times by what equals 6? Do you know?
3 times what?
Yeah,
2.
you tell me. 3 times by what
2.
number equals 6?
3 times 2.
Nice. Because the bottom or the denominator got 2 times bigger, we are going to do the exact same thing for the top. So 3 times by 2 is 6. So what is 2 times by 2?
4.
Nice. So we could have rewritten, instead of 2 and 2/3, we could have said 2 and 4/6 plus that other 1/6 of an hour to cook that half of a pound. What's that answer? What's 4/6 plus 1/6? Do you know?
You said 4, 6 plus 1, 6. 5, 6.
That's it. So our answer would be 2 and 5/6. So reasoning it out is awesome. But a problem like this, to finish the problem just using reasoning, we got into some really heavy duty math and we wound up working a lot harder. And so I like using reasoning, but to figure out my equation, to figure out, does it make sense? Should I add here, subtract, multiply, or divide? And so once I figured that out on this problem, that I needed to multiply, this is how I solved it. I knew I was going to have to do 1/3 times by 8.5. And so I was going to have to rewrite 8.5 as 17 halves. And then I multiplied across and got 17/6. And then I turned that into a mixed number, which was 2 and 5/6. So Tylisha, how did you do on that one?
Horrible. I didn't do it at all. I was so lost. I was so lost.
And word problems are very tricky. And so I'm going to tell you right now, next week, I will definitely be doing word problems again because we need to finish this one. And I might actually throw in a couple of more practices with some of the fraction problems because these are very tricky. And in my experience, it's these types of fraction problems that my students struggle with the most. So I'm going to jump ahead to say, great job, everyone. We'll be doing word problems again next week. I'll be doing a few more with fractions, but then we're also going to get into using positive and negative numbers. And I might go ahead and include some with the simple equations and maybe some multi-step equations. We'll see how brave we get. But anyway, I hope that everyone has a great week. I hope everyone stays safe. And I'll see you soon.